Hi everyone and welcome to this video lecture. My name is Emanuele and I am Italian. In my background I have a master's degree in biological science, a doctorate in neuroscience, and I'm also a physical therapist graduated from the ESP. I would love to bring my knowledge and expertise and my passion for teaching to the ESP family. So the topic of this lecture is the acute effect of exercise on the body. In particular, we are going to look at the cardiovascular changes and the respiratory changes that happen during exercise. So to do that in a more visual way, I'm going to bring you on a bike ride with me in the area where I'm from. So as I start pedaling, my muscles are working more, so they are consuming more oxygen, and they are producing more CO2. Also, the pH of the blood is decreasing. So to face all these changes in the muscle metabolism, the muscle needs to adapt. So the blood circulating needs to be more. The cardiac output is at rest around 5 liters per minute and increases during exercise up to 20-40 liters per minute. This is done by increasing the heart rate, which is actually increasing even before the start of the exercise as an anticipatory response, and it keeps increasing during exercise as the intensity increases. Also, the stroke volume is increasing, so the quantity of blood pumped by each contraction of the heart, which is increasing until a certain point where it plateaus. If we look at the blood pressure, the systolic blood pressure is increasing from a resting level of 120 up to 170 and even more. This increase in blood pressure is actually helping the blood to reach the muscles in a more efficient way. Also, the blood itself is changing. So if we look at the blood composition, we can see that during the exercise, the blood is losing some of the plasma component, leaving the blood itself more concentrated in erythrocytes. So the hematocrit increases and also the efficiency of the blood. Also, the blood flow is changing. So at rest, we only have 15 to 20% of blood in the muscles, whereas during exercise, this percentage can increase up to 70-85% of blood in the muscle. This blood is coming primarily from kidneys and digestive system. So let's have a look at the respiratory changes. The pulmonary ventilation is increasing from a resting level of about 5 liters per minute up to 80-90 liters per minute, even 120 for big athletes. This increase in ventilation is actually starting even before the beginning of the exercise as an anticipatory response. As I keep pedaling, my muscles are burning more oxygen. The blood coming to the muscles from the artery is not changing its concentration of oxygen, but the blood that is leaving the muscle is decreasing its oxygen concentration quite a lot. So the arterial-venous difference in oxygen concentration gives us an indication on how efficient is the tissue in extracting the oxygen from the blood. The oxygen consumption of the tissue is depending on the blood flow to that tissue, so the cardiac output, and the efficiency of the tissue in extracting the oxygen from the blood, so the arterial-venous O2 difference. And this is summarized in the VO2 formula. The VO2, so the oxygen consumption, is increasing during exercise as the intensity increases, and this correlates linearly with the heart rate. So we can use the heart rate as monitor of intensity of exercise in a very simple manner with the Carbonen formula. All we need to know is the resting heart rate of the person and the maximum heart rate of the person. So in my case, the maximum heart rate is calculated by 220 minus my age, 35. That gives me 185. My resting heart rate was 65, so that gives me 120 of heart rate reserve. And this value I can use to calculate the intensity of the exercise. For example, if I want to train at 60% of my intensity, I have to do the 60% of my heart rate reserve, which would be 72, plus my resting heart rate, 65, which gives me a value of 137, which is 60% in my case. At the end of the exercise, the muscle work is decreasing, so is the activity of the cardiovascular system and the respiratory system, which slowly go back to the resting level. And now it's my turn to go back to the resting level, and I hope to see you soon. Ciao!